is 7.1, start of new unit on sequences and series. So most of 7.1 is review from your Math 1. If you recall, we did sequences, um, arithmetic and geometric sequences. In 7.1, we're going to review that and include series. That would be the only new part, which is towards the end of the lesson. So what is an arithmetic sequence? A sequence in which the difference between any two terms is constant. So you're going to be either adding or, let me see here, free draw. If you're going to be adding, so plus, or subtracting in the list of numbers. So that's what it is, okay? The common difference is what you're adding or subtracting by, and we usually use variable d to denote that. So if you look at this first set of examples here, we see this list here, 5 to 8 to 11, 14, 17. You are adding by 3 each time. So d, the common difference, is positive 3, okay? And it looks like they want the next 3 terms as well, so 20, 23, and 26, okay? We see here in the second example that you can also subtract in the list of numbers. It just means that the common difference is minus 7. Okay, and then the next 3 values would be negative 12, negative 19, and negative 26. That's all it is, right? Now it does say determine if the sequence is arithmetic. So again, that means if you are adding or subtracting for each one. So if you look at number 3 then, 1 to 2, 2 to 3. So we did add by 1, add by 1. But then 3 to 5, we added by 2. 5 to 8, we added by 3. So no, this is not an arithmetic sequence, okay? Number 5, same thing, right? We add 10, but then we added 5, then 5, and so on. Point is right here, this was not a common, an arithmetic difference, so no. Okay, so you would just look at the list of numbers and see, are you adding or subtracting by a common value? Okay, the common difference. So the arithmetic sequence formula, this helps us find any term on the sequence. And we read this as a sub n equals d, the common difference, times n minus 1, plus a sub 1 means the first term. A sub 1 is the first term, and of course d is the common difference. You might see in other help videos or in the textbook, some resources write a sub 1 first, and then the d times n minus 1 second. So I left an example on the board in blue. If you guys see that, I actually wrote it as a sub 1 first, and then the d times n minus 1 second. It doesn't matter. Okay, you end up with the same expression anyway. So if you look at this then, how do you write the formula for an arithmetic sequence? You would look at the list of numbers, identify a sub 1. We see here a sub 1 is negative 5. That's the first term on the list. And then whatever the common difference is. So we were adding by 4 each time. That's 4. Okay. Now, there's 2 ways you can write your answer. Okay. One form is you just plug it into the formula, which would look like this. Okay. And this should just be minus, right? Positive minus, this turns just into minus. So this is one way you can leave your answer, okay? But you can simplify this. So in other words, if you distribute the 4 into the n minus 1, you get 4n minus 4, and then minus 5, these two combine to make negative 9. This is also a form of the answer. This one is considered simplified. Let's see if I can write this. Okay, they're both fine, and you should just know that both versions of the answer are the same thing. Okay, so again, this top red one is fine, and this one as well. Okay, sometimes if you know that you set it up like this, but none of the answer choices or the answers in the answer key don't seem to match, that's because it's probably written like this instead. Okay, so once you plug in and find what the formula is, then you can find whatever the indicated term is. So for example, here, look, they wanted you to find the 24th term. A sub 24 means what is the 24th term? Thanks to the formula, all you have to do then is plug in 24 into it. So 4 times 24 minus 9, that's what this here is showing. And when you simplify this, you get 87. That means if you continue this list on right here, so starting with -5 and you're adding 4 each time, the 24th term in this list will be 87. Okay, and that's what it means. So looking at number 8 then, you're subtracting by 9 each time. Okay, so D, the common difference is -9. And the first term, a sub 1, is 20. Again, that's the first list, the first number in the list. So when you plug it in, right, you end up with two formulas. Again, you can either leave it like this, or you can simplify it by distributing the -9 in to get this next line here, and then 9 and 20 make 29. So again, either one will work. To find, in this case, they want the 15th term. You plug in 15 to the formula. Again, either this one or this one. And when you simplify it, you get -106. That means the 15th term in this list, if you kept going, would be -106. Okay? And that's what's happening in the remaining two examples here. Look, a sub 1 is -6. The common difference here, we're subtracting by 3 each time. So here's the formula. And when you plug in 38, you can find the 38th term, which would be -117. Okay? Now these here won't be too common, but just know that sometimes the common difference could be a decimal, right? So here's going up by 1.5. So just, yeah, be aware. Sometimes you might work with the decimals like this, but the work does not change. Okay? All right then. So then how do you use the arithmetic sequence formula to sometimes solve problems that require the use of it? So right here they want us, look, given um, two terms of a sequence, write the rule for the sequence. When they say that, they want the general rule. So think about it. If you have the first term to be 3, and you know the third term to be -7, this one's not too bad, I guess, but you can maybe, decipher what what D would be. But you can use the latter term, this guy, and then whatever the other piece of given information is, to be able to solve for D. So look, this is the formula right here, right? A sub n equals D times n minus 1 plus a sub 1. They gave us a sub 1 right here to be 3, right? So look, they plugged in 3. Okay, and then they told us the third term is -7. So that means -7 equals D times n became 3, because they tell us the third term, right? So 3 minus 1 is -7. You see that? So all they did was they plugged in this piece of given information here and this one into this. Okay? And then by using that, then they can solve for D. Look, you can distribute D in, which gives you, well, you don't have to distribute 3 in. 3 minus 1 is 2. 2 times D is 2D plus 3. Okay, so subtract the 3 over, you get -10 equals 2D. Okay, divide by 2, D equals -5. And then you use this then, so -5 into the formula here. Okay, and then um, the first term, a sub 1, and then you can either, again, leave it like this, or distribute the -5 in to simplify it into this. And then they did want, in the directions, once you find whatever the arithmetic formula is, to plug in 12 into it, and then you can solve for um, the indicated term here. Okay, so check this one out. Again, a sub 1 is -17. Okay, so again, plug it into the formula, the general formula here, -17. And then the 24th term is 6. So 6 equals D, we don't know what D is, parentheses, n is 24, this is the 24th term, minus 1, minus 17. Okay, so again, it's just replacing this with the information they gave us. And then if you distribute the D in here, you get 20, sorry, you don't even have to do that. 24 minus 1 is 23. 23 times D, 23D, minus 17. Okay, and then solve for D here. Add the 17 over, divide by 23, you get D is 1, and then you use this now to be able to replace it here and write the general formula that we were doing in the prior page. Okay. And then you can find the indicated term like that. So again, this is all Math 1 review, okay? So this is what you did in Math 1 actually. So hopefully we remember enough of it, or this helps us recall how we would solve problems then. The arithmetic series, this is the new part. This is the Math 3 part, okay? And we use this formula here, okay? So in a series, you find the sum of the list of numbers. So all of these problems here, we were, finding the general formula and what would be the 24th term, for example, in this one, right? In a series, instead, we find the sum of the list of numbers. So in other words, going back to here, right? If you have 38 numbers in this list, what would the sum be? So this plus this plus this plus this, all the way into the last number, what would you get? Okay, so that's what the series is. So n right here is the number of terms in your sequence. A sub 1 is the first term of the list of numbers, and A sub n, this is the confusing one usually students make a mistake with, is the last term of the sequence. So this formula here is very, very useful because if you know the first term of the number of the list and the last term of the list and how many there are, then you can use just by plugging into this and get the full list, the full sum, sorry, of the list. So check this out. Sometimes, so here's the first example. So here's the sequence, right? This is now called a series because instead of being separated by commas, now we have plus, okay? And we can see that the common difference here, right? We're adding by 2 in each term, right? And what would be the sum of numbers then if you have 10 a sequence or a series of 10 numbers? So what do? We need the last term of what this list would be. So we now can solve for it using the arithmetic sequence formula. So we know it's going up by 2 lists. So D is positive 2. We're going up by 2. And A sub 1 is 2, right? That's the first number in this list. So look, D times 10 minus 1, because n is 10, plus A sub 1, which is 2. We find that the last number in the list, A sub 10, would be 20. Okay? So in other words, we have to find the last number in the list, right? Because that's what the formula requires. So then now we can plug in, look, the sum of 10, a series of 10 numbers equals 10, because there's 10 numbers, parentheses, the first number in the series is 2, plus the last number in the series is 20, which we found here, divided by 2. Again, this is the formula. And then all you got to do is simplify this. 2 plus 20 is 22. Divided by 2, you get 11. 10 times 11, 110. Okay? And that's it. You just found the sum of the series of 10 numbers to be 110. So it's a neat shortcut instead of having to write out the full list, right? And then add each term, for example, in the calculator. Now, this one's not too bad, but you will be asked eventually to, find the sum of, say, I don't know, 20 numbers, right? But this formula will help shortcut our work. So check out 14 then. So again, here's the list, right? Here's the series. We see that going from -6 to -19, and then from -19 to -32, it looks like we are subtracting by 13 each time. And the first term in this series is -6, right? That's this one right here. So using the arithmetic sequence formula, here's a sub 1. So a sub 1 became -6. And the common difference is -13. Parentheses, n minus 1, n is 8. Because we need the 8th term. We don't know what it is right now. So a sub 8 equals -13 times 8 minus 1 minus 6. When we simplify that, we get -97. So that's this guy right here. That's the last value, right? That's a sub n. And so a sub 1 is -6 minus 97, the last term, divide by 2. This gives us 51, negative 51.5 times 8, because there's 8 numbers in this series, we get negative 412. So that means, again, the 8 values in this series, when we subtract 13 each time, if you add them all up, you get negative 412. So very neat. Okay, in these last two examples, the same thing is still going on, except the summation changes. This summation, okay, that looks like this. This is in math called sigma, haha, okay? And we use this also to denote when we have a series, okay? So this is, in other words, the formula of the sequence. It's just written in x terms, but it's still the same thing. So check it out. When you plug in 1 as x here, 6 times 1 is 6, minus 4 you get 2. So that means the first term is 2. The last term is given by the top here. So this one says, starting with 1, the first term, there are 12 numbers in the sequence. That's what this is saying, okay? So to find the last one, you plug in 12 here. 6 times 12 is 72, minus 4 is 68. This is the last term. This is the 12th number in this series, okay? And it also happens to tell you how many values are in the series, 12, since you go up to 12. So from 1 to 12. That's how you read this, okay? So plugging into the formula then, sum of 12, sum of a series of 12 equals 12 values, the first term 2 plus the last term 68 divided by 2. This gives you 35 here times 12, 420, okay? If you look at the next one, this one's interesting, okay, because notice that we have m of 8, that's a little 8, and then you go up to 17, okay? So it doesn't change the fact. So all this is saying is there's a series of, 17 numbers. However, we only want to find the sum starting with the 8th number going all the way to the last number. So only part of the list, in other words, okay? It doesn't change it though. This becomes your ace of 1 because you're only counting from the 8th term to the 17th. The 8th term is essentially the first term of that list of numbers. So what you got to consider are two things then. So this is your ace of 1. So negative 2 times 8 is negative 16, plus 3, you get negative 13. Okay, and then the last one number is still 17, the 17th term, right? So plug it in, you get negative 34, plus 3, you get negative 31. Now n is not 17. There's not 17 numbers in this list of numbers. It's from the 8th to the 17th. So how many numbers are there? There are 10 numbers in this list. So from the 8th to the 17th is 10 values, okay? That's why n is 10. So you plug in 10, the first term minus the last term, divide by 2. You simplify that, you get negative 220. Okay? And that's all there is to it. So practice this for today. Okay, it is practice A and practice B. Just because a lot of those problems is just, working with arithmetic sequences, which is review. Okay, but pay close attention to the series. I'll have the keys posted on Google Classroom. Please work, okay, with even with the sub. This is due next time. Okay, no excuses. You guys should have this done. Okay, and I'll see you guys next time.